Okay, today my students are working on identifying independent and dependent variables and figuring out what type of relationship those variables have with each other. Now, I'm going to go ahead and write down independent and dependent here. Independent, dependent. And I guess I might as well, I'll write variables here. Okay. Now, independent variables are those variables in a situation that are completely on their own, not depending on the other variable. It's almost like they're the cause. The dependent variable is completely dependent on the independent variable. It kind of makes sense when you think of it that way. Independent, they're independent. Dependent, they rely on the independent variable to have some sort of effect on themselves. Let's look at a couple of examples. Let's say that I am having a party. And if I have, in this party, if I have a certain number of guests, and then I have to think about refreshments. For instance, we'll talk about like pop. We'll talk about pop. If I have 2 guests, then I want to have about 4 pops. I want to have about 4 pops because if somebody drinks one a little bit later before they leave the party, they might want another one. Another word for pop would be soda. If I have 3 guests, then I might need 6 soda pops. If I have 4 guests, I might need 8 pops, something like that. And so in this situation, the number of guests would be my independent variable, and the amount of refreshments, in this case soda pop, would be my dependent variable. I'm only going to get enough drinks depending on how many guests show up. So that's why this is the dependent variable. Now notice that as the number of guests goes up, the number of refreshments also goes up. When that happens, when you have a relationship like that, we call that a direct relationship. When one variable goes up and the other variable goes up, then you have a direct relationship. If you have one variable go down, for instance, if it turns out a guest decides not to show up, then I'm going to need less pop. If one variable goes down and the other variable also goes down, then that's an example of a direct relationship also.
Miss Jennifer wants to know whether you are at home for recess.
We're going to be probably going outside for recess. She can take you all to the gym. Now, let's look at another relationship. Let's say that we've got, in this situation, we're talking about the number of students and how much time I can spend on each student. So I'm going to change this stuff. So independent, it's going to be the number of students. And my dependent, let me go ahead and readjust this. My dependent is going to be amount of time I could spend per student.
Well, good girl, come to the office.
Let's say that I've got, if I have just 10 students that I'm working with in an hour, then I can roughly spend about 6 minutes per student. If it turns out that I have 12 students in an hour, then I'm only going to be able to maybe work 5 minutes with each student. And if I were to have, say, 15 students, then I might work out to only have 4 minutes with each student in the course of an hour. Now, when I look at this relationship, this number of students is my independent variable, and depending on how many students I have, affects how much time I can spend with each child. And so the amount of time per student is my dependent variable. But notice something. When I have the number of students going up, then the amount of time I can spend with each child goes down. When you have a relationship like that, we call that an inverse relationship. When one variable goes up, the other one goes down. That would be an inverse relationship. Now, I've got a few other examples that I came up with to throw it out there. Let's look at some of these. Let's say that we talk about, let's talk about a family. But maybe the more children in a family, the less money for Christmas presents. You know, a family that has only one child, then they can spend more money per present. But if they have two children, it's going to cut their amount of money perhaps in half. So the number of children would be the independent variable. The money per present would be the dependent variable. And because as the number of children increases in the family, the less money per gift, that would be an inverse relationship. And I already talked about the number of guests and the drinks or pop or snacks at a party. And here I had one last one, the number of children in a classroom, the more seats that are needed. Like if I have 24 children in a classroom, I need 24 chairs. But if I have 26 children in a classroom, I need 26 chairs. The number of children in the classroom will be the independent variable. The number of seats in the classroom that I need will be the dependent variable. And because as the number of children goes up, the number of seats needed goes up, we have a direct relationship. Now, this was just a little example, a few little examples I want to go over with my students as they do some work with this today, and I hope it helps them. Now, if I were thinking about a math practice, an appropriate math practice that could go along with identifying dependent or independent variables, I would say number 6, be precise. If you are precise with your definitions of what is an independent variable, what is a dependent variable, then you can say that number 6, I was precise with my use of the definitions of those terms, and that could be your math practice. And I'm saying that to my students. All right, how many of you, my students, feels like this little talk I gave you helps you better understand it? Wow, I'm seeing hands all over the place. I'm seeing hands all over the place. Well, that's wonderful. In a few moments, you're going to be able to work in the groups, and you can show me what you've learned.